Welcome. In this video, we're going to talk through some selected density problems from page 4A. So the first question we want to look at is question 2. You have a piece of magnesium and a piece of silver that are the same volume, and will the mass of the silver be greater than, less than, or the same as the mass of the magnesium? Well, we're going to look up here at our table, and our magnesium has a density of 1.75 grams per milliliter, and our silver has a mass of 10.50 grams per milliliter. So this question is getting at the meaning of density. So what does density mean? Well, density represents the amount of mass per volume. So what that means, if an object has a greater density, so like in this case, silver has a greater density than magnesium, that means it would have more mass per volume. So if you had two samples with the same volume, the silver would have more mass in that space here. So the mass of the silver is going to be greater than the mass of the magnesium because it's got more mass per space. So if you look down here at question 3, if two objects have the same mass, which of the following must be true? And the correct answer here is C. So the mass tells you the amount of matter in the substance. Mass does not determine volume or what the material is or the density. So the amount of mass is just the amount of matter in a sample. Versus the density would be a ratio of how much mass there is per unit of space there. Let's look at some calculations here. So this one, liquid mercury metals poured into a graduated cylinder that holds exactly 22.5 milliliters. That looks like a volume. So I'm going to label that's a volume. And then the mercury weighs this, so that looks like a mass. So the mass is 306.0 grams. All right, and if we go back here to the top, and we're asked to calculate the density. Okay, if we go up here to the top in this equation, density is the mass divided by the volume. So let's go and do that down here. The density is the mass divided by the volume. So it's 306 grams divided by 22.5 milliliters. And if you stop and plug that into your calculator, you end up with 13.6 grams per milliliter. Notice that when you're doing these calculations, you should show your work. You should always label numbers with units. So is it grams? Is it milliliters? What is it? All right, so now here we have an unknown here. So we have some piece of metal. We picked it up. We don't know what it is, but we do know the mass is 165.7, and we know the volume is 46 milliliters. So we want to calculate the density and then identify it based on the table we were just given at the top of the page. So remember, density is mass divided by volume. So the mass is 165.7 grams. The volume is 46 milliliters. And then I'm going to plug that in my calculator, 165.7 divided by 46, and I get 3.6 grams per milliliter. And then my next step is I want to identify the metal. So if I scroll up here to the top, I can see I'm given a table of metals with various densities. And it looks right here that it looks like tin has a density of 3.6. So I'm going to say that my metal, here I've just identified, it is tin. Okay. So let's try one more practice problem here. So you've got a piece of metal where you know the volume and you know the mass, and you're trying to solve for the density. So density is the mass divided by the volume. The mass is 252 grams. The volume is 30.0 centimeters cubed. So sometimes we use milliliters for volume, sometimes we use centimeters cubed. And those are just different units you can use. So 252 divided by 30, you end up with a density of 8.4 grams per centimeter cubed. So if you look up here at the table, 8.4, it looks like that is brass, which brass is an alloy, which is a mixture of metals. Kind of cool. Okay, so we just identified that. That is brass. Oh, here's another good question here to think about. So you have two objects that each have a mass of 5 grams. One has a density of 2.7, one has a density of 8.4. Which object has the larger volume? Explain your thinking. Okay, so you've got a 5-gram sample over here, and the density is 8.4 grams per centimeter cubed. And you've got a 5-gram sample over here, and the density is 2.7 grams per centimeters cubed. So there's a couple different ways to go about thinking about this problem. You could do some mathematical work, but one thing I'm looking at right now as I write this down is I'm going to notice that this one has less density. So that means the, mass per volume is smaller. And so it's got a smaller mass per volume. So what that means is that the mass over here in this sample needs to be more spread out than the mass over here on this one. So if you're picturing these 5 grams over here, it's going to take up a much bigger space than this 5 grams over here. Because since this object is less dense, it's got less mass per volume than this object over here. So that makes sense kind of visually, what I'm looking at over here. This one is then going to have a larger volume. Because in order to have, let me think of it, in order to have a smaller density, it is going to have the same mass in a larger volume. That's kind of what we're trying to represent here. So that same amount of mass is going to be more spread out in this sample because its density is smaller. If you're interested in doing this mathematically, you could also use this equation up here, and you could calculate what the volume is. You could say the volume equals the mass divided by the density, if you're interested in doing some algebra here, and you could calculate the two volumes. So volume is mass divided by density. So over here, it would be 5 divided by 8.4. You can solve for what that would be. Over here, it would be 5 divided by 2.7. And when you stop and solve, you should find that this one over here on the right gives you a larger volume. So those are just kind of two different ways of thinking about it. All right, so hope this helps with density. Kind of want to get some of the conceptual questions with density. That'd be like question 7 and question 2 and 3. And then you also just want to be able to calculate density like questions 4, 5, and 6. Please reach out to me if you have questions.